Hello everyone, in today's video we're going to be talking about arithmetic sequences. Okay, so since this is the sequences and series unit, um, before going ahead and talking about just arithmetic sequences, I wanted to quickly talk about the difference between arithmetic, geometric, sequences, and series. So I wanted to talk about what all of these mean. So let's start with sequences or a sequence. So a sequence in math is essentially a list of numbers. So a sequence of numbers is a list of numbers. Now, this sequence or list of numbers could be arithmetic, which we'll talk about in a second, could be geometric, or it could be what we'll say other. Um, so if a sequence or a list of number has the specific property that where the terms in that list have a pattern to them, and that pattern is adding or subtracting a number to get to the next term, we call it arithmetic. For example, here's an example of an arithmetic sequence: 2, 5, 8, 11, 14, dot, dot, dot. So this is a list of numbers, and by the way, sequences could be finite or infinite. So finite meaning it ends after maybe 5 or 6 or 7 or however many, and infinite meaning it can keep on going forever. So I should add that that all of sequences and series can be finite or infinite. Okay, so so the main point with arithmetic sequences is that they have a pattern, and that pattern is the numbers going up and down in a predictable manner. So going up by a specific number or down by a specific number. In this case, the pattern we have here is that the terms are going up by threes, right? So all of these, in order to get from one term to another, we have to go up by 3. Okay, we could also have an example like this where we go down by a number. So 10, 8, 6, 4, 2, 0, -2, and so on. So this is also an example of an arithmetic sequence. It's a sequence because it's a list of numbers, it's finite because it ends, and it's arithmetic because every time it goes down by the same number. In this case, -2, or goes down by 2. That's an arithmetic sequence, and the number that we go up or down by doesn't have to be an integer. It could be a decimal or a fraction, and we refer to that number as the common ratio. Sorry, common difference. We refer to this number as the common difference, and it has the symbol d. We give it the symbol d. So geometric sequences we'll talk about later in 2 or 3 videos, but essentially geometric sequences are lists of numbers where in order to get to the next number, you multiply or divide by a specific number. So in this case, I've multiplied by 2 every time to get to the next number. So this would be a geometric sequence. And the number that you multiply or divide by every time to go up in terms is referred to as the common ratio. Okay, and if the list of number follows some other pattern that's not arithmetic or geometric, we put it in the other category. Okay, so the next thing to talk about is what a series is. And a series is fairly similar. So series is the sum of a sequence. The sum of a sequence. So we could take any of these lists or sequences that we had on top, and instead of putting commas between them, we can add them. So this is one example. Here's another example. And these would now be referred to as a sequence. Two separate sequences. Sorry, series. Two separate series. So this and this are series. And so in this case, this would be an arithmetic. These two would be an arithmetic series. Whereas if we had the sum of a geometric sequence, so a geometric list of numbers, for example, if we had something like 2 plus 4 plus 8 plus 16 plus 32, this was the geometric sequence example I gave earlier, where we multiply by 2 every time. This would be referred to as a geometric series because it's the sum of a geometric sequence. Okay, so those are the key differences between arithmetic and geometric sequences and series. Today, we're just going to be talking about arithmetic sequences. So I'm going to put this example back here. Okay, so we're going to put that aside and only talk about arithmetic sequences. Okay, so we already talked about what a arithmetic sequence is. Now I'm going to introduce a couple formulas that will allow us to calculate various things when it comes to arithmetic sequences. So the first formula is this. This is called the nth term, or general form / term. We'll call it general term. The nth term or general term formula. So the nth term of a arithmetic sequence is given by a1 plus n minus 1 times z. Now let's define all of these variables. So this, the an, is the nth term of a sequence. So for example, a1 represents the first term of a sequence, a2 represents the second term, a3 represents the third term. So in our example of 2, 5, 8, 11, 14. A1 would be 2. A2 would be 5. A3 would be 8, and so on. Okay, so that's what this AN represents. Now, A1, we talked about this. This is the first term. And N here is the term number that you're trying to find. So this formula, like I said, allows us to find the nth term of a sequence, and n represents the term number we are trying to find. So we'll call this term number. We'll of course do an example in a second, and this will make more sense. And D, we saw this upstairs already. This is the common difference. Okay, I'm going to give you a formal formula for finding the common difference. So the common difference is given by taking any term in a sequence and subtracting the previous term from it. So this is the general mathematical way of saying take any number, subtract the previous number. For example, we already know that the common difference in this sequence is 3, right? Because we have to add 3 every time to go to the next number. And that's the common difference is defined as that number. So one way we can find this is take any one of these numbers. So let's say 8. Subtract the number that comes before, 5. And we'll get 3. Okay, which is our common difference. You could have also taken 14, subtracted 11 to get 3, or taken 5, subtracted 2 to get 3. So the common difference will, of course, always be the same. All right, now knowing this formula and what each of its parts represent, we can calculate, let's say, the 7th term in this sequence. So we have the first term, second term, third term, fourth term, fifth term. Let's say we wanted to calculate the 7th term. So let's do an example. We'll say find the 7th term in 2, 5, 8, 11, 14, ... So the 7th term is represented by a sub 7. Okay, so this is the formula I'm using. Let's highlight it in yellow. A sub 7 is equal to A1, our first term, which is 2. That's right there. Plus the term number we want to find. We want to find the 7th term. So our n is 7. We'll put 7 here. Minus 1 times d, the common difference. What's the common difference here? It's positive 3. So the 7th term, or A7, is equal to 2 plus 7 minus 1, which is 6, times 3. So A7 is equal to 2 plus 18, which is 20. Okay, so our 7th term is 20, and we can confirm this. So this guy is A3, this guy is A4, this guy is A5, or the 5th term. Let's calculate the 6th term, so add another 3, we get 17, and add another 3, we get 20, so This is a 6, and this is a 7, or the 7th term. So we can see that it works. Okay, so that's the general term formula. It's a very important formula and very useful as well. Next, I'll briefly talk about where this formula comes from for those of you that are interested. And the reasoning behind this is very simple. Let's go back to the example I had down. So 2, 5, 8, 11, 14. So to find any term in this sequence, like the 7th term or 10th term or whatever we want, we can essentially do the following. We know that the separation between all of these numbers is the same. In our case, it's plus 3. So what we can do is start with 2 and add to 2 as many common differences as we want to get to the next term. So if I want the second term, I only have to add a single common difference. If I want the 4th term, I have to add the common difference 3 times to get to that point. So notice that if we want the 4th term, we have to add the common difference 3 times. If we want the 2nd term, we have to add the common difference once. So we always add the common difference 1 less many times than the term number we want. So that's why we take the term number, we subtract it by 1, and then we multiply it by the common difference. So this is saying we are adding to 2 1 less than the term number we want times the common difference. Okay, so that's where the formula comes from. Another, or a word of caution here, sometimes in your class you might see your teachers use Tn instead of An and T1 instead of A1 in the formula. So this is also common. Sometimes we see Tn is equal to A plus n minus 1 times D. So these are more or less interchangeable, Tn, An. So be aware of that. Okay, that's going to be it for this lesson. I will talk about one last topic in this video before going into the next section, which is just doing practice problems. But that's optional, and I haven't prepared any sample problems to do in the next video on this next topic. So this next bit is only for those that are interested. And it's on arithmetic series, arithmetic means. So in arithmetic series and sequences, we could talk about something called an arithmetic mean. So what is an arithmetic mean? A mean is just an average. So mean is the word we use in math for average. And an arithmetic mean essentially means to have evenly spaced numbers between two other numbers. Here's what I mean. Let's say somebody asks you to find 3 arithmetic means between 10 and 15. To find 3 arithmetic means between 10 and 15 simply means to find 3 numbers that are evenly spaced between 10 and 15. So we want 3 numbers that sort of divide the difference between 10 and 15 into equal intervals. Okay, and the formula for this is also very simple. we can see from this very basic image I've drawn and the explanation I gave, if we want 3 arithmetic means between 10 and 15, that means we want to have 3 numbers that are evenly spaced out, and there's going to be 1, 2, 3, 4 equally spaced intervals between them. So to find arithmetic means, in this case 3 arithmetic means between 10 and 15, we would take the difference between 10 and 15 divided by the number of spaces between 10 and 15, 4, which is 4, right? It's always one more than the number of arithmetic means you want to have between your numbers. So if we want to have 3 arithmetic means, we'll have 3 plus 1 on the bottom. And this will be the spacing between your arithmetic means. So 15 minus 10, that gives us 5 over 3 plus 1, 4. So this is going to be 1.25. Okay, so this is telling you the spacing between your arithmetic means. If we want to find the 3 arithmetic means now, what we can do is take 10, start with 10, add 1.25 to it. So that's going to give us that the first number is 11.25. We can add 1.25 again to get the next arithmetic mean, which would give us 12.5. And we can add 1.25 one more time to get the last one. So this would give us 13.75. Okay, and you can see that if we were to add another 1.25, we would end up getting 15. So hopefully this idea makes sense. The key thing to remember with arithmetic means is that we want to essentially find numbers that equally divide an interval between 2 other numbers. Okay, and the method we used was to take the difference between the 2 outer numbers, divide them by 1 more than the number of arithmetic means we want, and use that number to generate the arithmetic means. So to finish things up, I'll try to put this in a little formula for you guys, and we will call it a day after that. So to find the arithmetic mean difference, so this is the difference between the arithmetic means, we will take the last number. Let's do last number sign minus first number divided by number of arithmetic means we want plus 1. So for those of you that like formulas, this is a nice little formula you can write down and add it to your sheet. All right, hope you enjoyed it. If you have any questions, put it in the comment section. I'll do my best to answer them. See you guys on the next video.